Okay, so I'm going to open what I sent to you guys. Everything started with Lillian asking some questions. And I thought, oh, okay, this would be a good time to actually talk about it rather than just attempt with that one question. I think she messaged me her updated findings, but I haven't been able to check through Lillian. I will and get back to you as soon as I can. Okay, so thanks for bringing that up. And then I thought, okay, we might come across this even in more topics. Even in vectors, we'll be dealing with something similar. So I thought, okay, why not just discuss from parametric to Cartesian before we move to the next topic we're supposed to start today. We can always start that tomorrow. And I also found a video about orientation. I was trying to compile some questions and I was trying to watch my machine learning videos online, and some kind of recommendation came up, and I thought, oh, okay, you guys will find this useful about the possible orientations of the 3x3 possibility. And it was well explained, even beyond my explanation the last time. So which I was thinking maybe some of you may not understand what I explained. So let me see if I can find the video. All right, got it. So let me share this with you. Can you see my screen? So I'll send you this link, but I want us to watch it together. Okay? Can anyone hear the video? Oh. Uh-oh. Okay, that's weird. Let me see my settings, my audio settings. Microphone. I think the same system should be adjusted. Try this. It's already in the maximum volume. How about now? Is anybody here now? Not really? Okay, I'll just send you the link. So I'll send you the link. It's a 7-minute video. Okay, and you could actually watch it later. So let's move on. I'll send you the link. That's the link. And I'll also post the link online so you can just check it out later. Have you got the link, everyone? Good. All right. So for now, let's focus on this. Okay, let's focus on this. So we might come across problems that require conversion between the two, parametric and Cartesian. Then the idea we're about to discuss today will be useful. So I've been able to gather 70 questions from different questions and different online sources, different different types of situation actually. So we will take some of this, maybe a few of this. You do some practice also. Then we'll take some of this as well. So now algebraic form or Cartesian form, this is the same thing. So basically, the parametric form involves a parameter. I've just decided to use t. Can everybody hear me? I want to be sure of that. Good. So parametric form involves a parameter. I just use t. It could be lambda, it could be w, depending on, but t is like very common variable. So rather than say x is equal to t, it could be in this form as well, x of t. It means x is a function of t, y is a function of t. Does that make sense? So writing in this form and writing in this form is the same thing, basically. Got it, everyone? All right. So it's just notation, okay? So don't panic. Like, oh my God, no, this looks different. No, it doesn't. It's the same thing. Even as a matter of fact, I may decide not to write it in this form. I could write x of t and just use that as a notation. But this is a common notation as you prepare to move to university. This is a common notation you'll experience probably particularly in maybe courses like partial differential equations or ordinary differential equations anyway, any form of differential equation. So you can see in some questions I used it. I should have been more uniform by putting it here as YT. I will adjust that and repost it on Edmodo and also put it on our Google Drive link. So your parametric form involves T. However, your Cartesian form does not involve T. So which means T is eliminated to get this type. So the question is, how do we move from here to here, and how do we move from here to here? So there are some different type of questions that we might have, equation of circle, in exponential form, logarithmic form, and things like that. So let's begin with this type, eliminating t from this. Some things I will introduce are things that you are not doing now, trigonometric ideas. They are in the IB past paper, so even if I test it during any assessment, you have the IB, no, not IB past paper, IB booklet, exam booklet, okay? Remember the formula booklet? So even if I test it, you don't have anything to worry about if you are not familiar with those trig identities yet. I've also been able to organize how I want to do the teaching. So we will go to topic 2, then we'll go to topic 3, and the fourth one will be topic 5 before topic 4. Okay, topic 5 is calculus, and topic 4 is calculus. Okay, and topic 4 is probable statistics and probability, and this is calculus. Okay, so we'll do calculus before that because it has a lot of application, but we need trig to understand calculus better. So I've decided that that's how we're going to do it. Anyway, so some of the idea that we use here are trig ideas, but I will only restrict it to the simplest of the trig identities. Okay, like sine square plus cos square is 1. We'll explain that in a bit. Then we'll use that. So just remember, sine square plus cos square is 1. You will also test that in your calculator to see that it works for all situations. Okay. So without wasting further time, we're going to begin with this. So let's go to the board, everybody. And let's write the topic as parametric and algebraic forms. So algebraic and parametric forms. I think I'll call it Cartesian, so it rings small there. Doesn't matter anyway. we can all see my whiteboard. Now, our objective is simple, to be able to convert between the two forms. That is summary. My video isn't obstructing the board. Please confirm that you can see everything that I wrote on the board. All right, thanks. So the first thing we're going to do is to pick, okay, let me put it this way. The simplest form of notes is that Cartesian form does not involve the parameter. Parametric form involves the parameter, basically. Okay, so let's say the difference between the two. Cartesian no parameters. Okay, equation of x, y, and z in some cases, if you have a 3 by 3 equation. But in parametric, okay, h of x, y, and z are expressed separately in terms of a parameter. Okay. Parameter could be t, say t, depending on any notation. So I will use t for this class. You can see this as some kind of difference. So if you want to solve, want to change from one to another, for Cartesian, you introduce your t. So Cartesian to parametric direct it to properly. Express variables separately. Okay. But if you want to change the other way around, so parametric to Cartesian eliminates t. Okay, eliminate t. Just eliminate t, of course. We get this? Yeah? All right. Okay. So I'd like to move on. Yeah, move on. Okay. Where is crystal clear here? Okay. All right, so let's begin with a simple case, and I want you to attend that first. Let's begin with a simple scenario. So I want you to try it first. So maybe I call it a starter. Okay. So I'm going to be considering question 1. Okay. Write in Cartesian form. That is eliminate T. Okay. So let's pick the simplest, which is question 1. X equals 2, y equals 3t plus 5. That's easy, isn't it? So can you write it as an equation without involving t? You can type in your comments. This is a short one, so there's no need to send the workings to WeChat. X equals 2t. X equals 2 squared is 2t. X equals 2 squared, y equals 2t. So take them one by one and solve them in your notebooks. Then maybe you can, I'll ask you to show me pictures later. Now, are you guys working on it or are you confused? It's working. All right. So open the question here. I think it's easier. Send to WeChat first.
So Daniel,
Yeah.
is that a 5 times root t or a fifth root?
5 times root t.
Okay.
Maybe my 5 didn't get enough sleep. No, you don't have to arrange to put on one side. It's perfect the way it is. 4x equals y squared. That's good. Okay, shall we do the first one? Has everybody done the first one? Yeah, okay. So it's easy. T is already, in terms of x, we just put it here. So just substitution, y equals 3x plus 5. Raise your hand if you got that. Okay. Okay. All right. So for this, we look for where is it best to make t the subject. So I think there are two ways I can look at it. I can say square root of x equals t from the first one. I just call it 1. I don't have to label it. Then from y equals 2t, this will be y equals 2 root x. So that's 1. Another way to express it, if I make t the subject from y equals 2t implies that y over 2 equals t. So x equals t squared implies that x equals y over 2 squared. So x is equal to y squared divided by 4, which means y squared equals 4x, which is what you get if you square both sides here. Can you see that? Does that make sense? So either way is fine. That was fine. Has anyone done question 3? Only Ethan? Lillian? Okay. Any other person? Can you type not yet if you're still working on it? All right. Okay, so I give you a minute or two. Work on 3 and 4. I'm gonna get me a coffee. You know, I told Nakita to come with virtual coffee today. She keeps posting those lovely, good-looking coffee on Instagram, and I'm jealous. And guess what? She had the audacity to flash it on my face by tagging me on her story. That's like news flash. I'm not gonna give you this, nice coffee, but I'm gonna show you anyway. Someone should call 911 and get arrested. All right, so I'm gonna get a coffee. int for 4. Okay, Mr. Cheng. When you have logarithmic function and algebraic function, your best option will be to make t the subject from the algebraic function, and this is your algebraic function. Okay? Yeah, of course. And leave it as log. As long as you eliminate t, nobody cares what your output looks like in terms of log, in terms of exponential, trigonometric, you know, nobody cares. So you can make t the subject here. You're confused. To make t the subject here is to remember that this is y equals square root of t minus 1, not y of t. Okay, y of t means y is a function of t. Got it, Mr. Cheng? Yeah. So you don't have to worry about this. Is notation. Just saying y is a function of t. So make t the subject here and substitute back. As simple as ABC. It might be best to maybe make t the subject here because it's less complicated. Rather than if t is a square root from here, then you put square root under square root. It doesn't make sense, right? Does everybody get that? I'm talking about question 3. So you look at it and you see which is most reasonable and which those approach is not so bad. For square root of what? For square root of square root, can't you just do fourth root? But before you could think of that, you have to like square root of square root. Yeah, you can do fourth root, but maybe there's another way to look at it. I said the easiest way. I'm not saying that's the only way. Look at somebody might have left this in this form, somebody might have left this in this form. It's just about raising powers on both sides. Of course, both are right. Okay? Unless you are to express y explicitly. Okay, like just making y the subject, then we can, care much about this. But the instruction when expressing in Cartesian form is not to make y the subject. It's just to express in terms of x and y, and it could be an implicit function. A function like y equals 3x plus minus 1 is explicit. But a function like y equals 2xy is equal to 3y squared is implicit. We talk about that a lot in calculus. So as long as it doesn't contain parameter t, then we're good to go. Does that make sense, Mr. Cheng? All right. You know, this dude was once called Mr. DMX in my class because he keeps telling me to listen to one particular album. What is he typing? Go get food. It's okay. I'm sure Karen has food on her desk. Yeah, if only we could see what she's doing. She has food. I don't trust that girl with food. Not anymore. Are you sure, Karen? Send her this time. I don't trust you anymore when it comes to food. You're my favorite foodie in the class. All right, I think the kettle is ready. What's up? Tobacco, what's up? You see, her sleep is messed up, so she just woke up. Calista, so that shouldn't be about me alone. You should say that to her. Her sleep is messed up. All right. Leo said, I have no idea. Number 4. Okay, Leo. So everybody got number 3, yes? All right, so we're going to just check from number 3 to start with. So if we make T the subject here, x over 5 is equal to root t, and that implies that x squared over 25 equals t. So y equals, now, which also implies that t squared, because I need t squared, I don't need t, right? So I could just get t squared. T squared is x to the power 4 divided by 65. So this means that 3 plus t squared implies that y equals 3 plus x to the power 4 x to the power 4. Oh, am I writing that way? Okay, so y equals 3 plus x to the power 4 divided by 65. So you could get this, or let's see. Can you see if I write here? Okay, and my video, my screen is not, my face isn't blocking, obstructing that, right? That's going to be shown. Oh, good. Okay, good. All right. Okay, so if you look at it another way, same question. So same question. If you make T the subject from here, actually I could just make T squared the subject from there. So from y equals 3 plus t squared, just t, like Mr. Chen said. Yeah, whatever. So y minus 3 equals t squared. So I could say t equals the square root of y minus 3. So x equals 5 root t means x equals 5 roots. That's what it's talking about. Okay? And square root of square roots is just the fourth root. So basically 5 fourth roots of y minus 3. Because it doesn't really look nice. So we could say x over 5 is the fourth root. And when you power 4 to both sides, y minus 3, not t. Okay, this is minus 3. So fourth root, y minus 3. So if you raise both sides to power 4, you get x over 6 to 5, which is this. Okay, and then you take 3 to the other side. Can you see that it's the same thing? Okay. All right, so for the fourth one, which Leo is talking about, let's put that here. So easy way, or easiest way is this. So I can say from y equals square root of t minus 1. It implies implies that y squared is equal to t minus 1, which implies that y squared plus 1 equals t. So x of t, which means x, log 2t will be log 2 times y squared plus 1. So that's the answer. Y equals log 2 times y squared plus 1. And it's log of everything. So anybody get that? Clarissa, what do you mean by no? No as in obstructing or... Yeah, you could expand. I expanded in. No, that's not, you mean lean, like ln. That's not the expanded, okay. All right, because it's not, this is log. This is log to base what if nothing is indicated? Base 10, yeah. Let's take note of that. You could also, if you want to make life complicated for yourself, which I would not advise, is try to make x t the subject from the first one. Of course, like I said, I wouldn't advise it. From x equals log 2t. So you agree with me that 2t will be 10 raised to power x. Where did the t go? T is gone. From here, this is it. Then you put it here. Flew away. Karen, do you understand now? Not really? Okay, I'll explain again. So, listen to this. Do you understand up to this point? Talk to me. Do you get it up to that point?
Well, like for the in the question, isn't it like y bracket t equals?
No, that is y as a function of t is the same as just y.
Oh.
It's simply telling you y is a function of t. Y is in terms of t. So t is the variable now. If you write y equals 2x plus 1, which is equation of a line with gradient 2 and intercept 1, I can write it as y in x equals 2x plus 1. I'm simply telling you why this equation y, x is the variable in it. X is the independent variable. So basically, this is telling you t is the independent variable. It's immaterial. It's the same as writing this. Does that make sense?
Yes.
All right. Okay. So is this solution clear now?
Yes.
All right. Good. Thanks for raising that up. Let's see. Like I said, if only one wants to be complicated, one wants to complicate life for his or herself, which I wouldn't recommend. Like, anybody want to do that? So from here, t is 10 to the power x divided by 2. Of course, that's not 5 to the power x. So from the second one, which is, I took it from here, so I put it here now. Y equals square root of t minus 1 implies that y squared equals t minus 1, not raised to power. So that means y squared equals 10 to the power x over 2 minus 1. And if I play the fraction, 2y squared equals 10 to the power x minus 2. So that's another way to see it, which you should be able to derive from here as well. Okay, be able to derive from this point, you could transfer the base, yeah? So you have 10 to the power x equals to y squared plus 1. Isn't that the same as this? Because this is actually 2y squared plus 2. Okay, can you see? This and this is exactly this. Does that make sense, everyone? Can you see the entire screen? Okay, good. So you can see, so basically this is easier. You don't have to complicate things. So when you have algebraic and logarithmic function, start from the algebraic part. In most cases, of course. Maybe there are some exceptional cases, I don't know, but the cases I've seen so far, that's the best thing to do. May I move on, please? I want to move to the next slide of my board. Okay, thank you. All right, so let's just continue to, look at different ideas by just going through practice. I call it starter, but now I think I should have just called it practice. It doesn't matter. It's a notebook. Nobody cares for writing it. So let's go to trying to see various form of problems. Aha. So the last one was question 4. So question 5. X equals cos t. Y equals sin t. Attempt that. Let's give it a try at least. Has anyone done that? Is anyone confused? You don't know what to do? I have no idea. No. This is the ints from trig identity, sin squared theta plus cos squared theta equals 1. If you have your calculator, bring out your calculator, everyone. If you have your calculator, type in yes in the chat. Okay, good. That's 2, 3, 4, 5, 6 people. 7, 8, 9, 10. Brandy, where you at? You don't. All right, maybe you can go online, scientific calculator. Let's check. So open the bracket in your calculator, sine, put any angle here, okay, and square that. And open cos, put any angle, the same angle, it has to be the same. Square it and put and get, what do you get? You get 1. So it's a trig identity. We'll talk about that in our trigonometric topics, which is next topic. Of course, you can add the equation. So that's what I was getting into. You can add the equation. So from that, so please take note of this, put it aside somewhere, trig identities. The useful ones for now, sine theta divided by cos theta is equal to tan theta. You can check that also in your calculator. Sine of any angle, cos of the same angle, okay? Take note of the answer. Then check tan of the same angle, you get the same thing. This angle has no limits, millions, thousands, nobody cares. Does that make sense, everyone? So this is sine squared theta plus cos squared theta is equal to 1. That's the one you just verified on your home. From this sine squared plus cos squared, we can generate 2 other ones by dividing through. We'll talk about that extensively in the next topic. Next topic, because we're not in topic 1, but we're not in topic 2 yet anyways. So if you divide all through by sine square, you're going to get 1 plus, this is cos over sine. Sine squared theta divided by cos squared theta plus cos squared theta. No, before then, so another way to actually write this second identity is sine squared theta is 1 minus cos squared theta. Then cos squared theta is 1 minus sine squared theta. It's still the same, yeah? So if you divide this by cos squared first, divided by cos squared is going to be sine squared divided by cos squared. Sine squared theta by cos squared theta, cos squared theta divided by cos squared theta, and this will be 1 divided by cos squared theta. So this is sine over cos, that's tan, so this will be tan squared. This is 1, this is sec squared. You know about sine, cos, and tan, right? The other 3 that we'll be telling you about is this 3. Well, this is topic 3, like I said, so I'm not giving you too much information. But for today's lesson, this is the only one we need. I just wanted to say this. Okay? So you know about sine, cos, and tan, yeah? So the other 3 are sec, which is secant. We just call it sec. Cosecant, which is complement of secant. So we just call that cosec. Check your calculation, see this. Then cotangent is the complement of tangent. So we just call that cot. So all these are inverses of what you already have. So sec theta is 1 over cos theta. Cosec is 1 over sin theta. That's the third letter in each of them. Cotangent is 1 over tan theta. Does that make sense, everyone? So basically, that's how I got this. Okay, that's how I got that. We'll discuss that, don't worry. I'm just mentioning that ahead. If I divide 2, same 2 above, by sine squared this time. So I'm going to have my sine squared theta divided by sine squared. I have my cos squared divided by sine squared. 1 divided by sine squared. So from here, sine over sine is 1. Cos over sine is inverse of sine over cos, so which means inverse of tan, and inverse of tan is cot. And 1 over sine is what? Cosec. Okay, and of course you can manipulate them. You can make tan the subject here, which is, you can put both of them together. From here, you can say tan squared minus sec squared is equal to 1. Or sec squared minus tan squared is equal to minus 1. So similarly here, you can take this away. 1 will be equal to cosec minus cot squared. I expect all this to be in your IB formula booklet. So we need this for anyone that forms trig equations, that is in form of trigonometry, especially the first one, which is this. This is all we need. This one actually, the second one. So square both sides and get x squared equals cos squared t. Then y squared equals sine squared t. And I can add both of them, x squared plus y squared equals cos squared t plus sine squared t. So which means x squared plus y squared is equal to 1. And that's all. Questions? Talk to me, people. Anybody home? Questions? Karen, no questions. Lana, Nakita, Clarissa, others? Okay. Expecting more. Crystal, Lillian. I need more replies, please. Callista, okay. More. Brandy, okay. Ethan, where's Leo? All right, please. So in this case, can somebody tell me what to do? Use your mic, please. Okay, maybe I call on one person. Crystal C.
So we know that cos square times t plus sine square times t equals 1.
Cos square times t or cos squared t?
Cos square t.
Yeah, it's not times, okay? So cos squared t, this is an angle. It actually means cos t raised to power 2. So they are not separated, it's 1. Okay, cos is a function acting on point t. Does that make sense?
Yes, and x squared will be cos square t.
Say that again, please.
X squared equal to cos square t.
X squared. Did you say x
sine
squared?
square?
No, X squared is what? Can you start over? Sorry, can you start over? From what we have, so what do you think we do first?
Y squared equal to cos squared t.
Good. Y squared equals cos squared t. And with this?
With this and x plus y squared equal to 1.
That's it. But don't just write 1. I need you to show me this first. That's what we need is the square of sine and cos, right? So which means one of them does not need to be changed. So x plus y squared is equal to 1. Thank you, Crystal. Does everybody get that? All right. So let's try this on our own. I'm going to ask you to try question 35 in the worksheet. I'll write it on the next. I'll put this on the board, or maybe I write it here, then you can do the correction on the next slide. So question 35 says x equals 4 sine t, y equals 4 cos t. Right. Make an attempt. If you're done, type in done. Don't post the answer. Done, okay. Done, good. Brandy, can you walk us through what you did?
So first I put x divided by 4 equals sine t and y divided by 4 equals cos t.
Good.
And then you square both sides for x and y, and then become bracket x divided by 4 square equals sine square t, and then y divided by 4 square equals cos square t.
Perfect. So
then,
what is the?
Then I said from sine 2t plus cos 2t equals to 1, and I put
no, not sine 2t, sine squared t.
Sine square t, sorry.
Yeah.
And then I said x divided by 4 square plus y divided by 4 square also equals to 1. And then I open the
bracket
square thing, and then become
good.
x plus y square equals, well, divided by 16 equals to 1. Yeah, wait, and then I put x plus y equals to x plus y divided by 4 equals to 1.
No. X.
Not sure can we do that.
No, you mean x plus y all squared?
Yeah, x plus y all squared.
You can't do that.
Cannot. Oh, so then just leave it as x squared plus y squared divided by 16 equals to 1.
You don't need it as fraction as well. You can clear the fraction. So very good, actually. You've done a good job. So it's not question 5. I think it's question 7. All right. So we're going to do it together in case anybody doesn't understand what you just said, but that's exactly what we need to do. So this is 4 sine t This is 4 cos t. So what he has done is x divided by 4. X divided by 4 equals sine t. Y divided by 4 equals cos t. Square both sides, x divided by 4 squared. That's what it's saying. Equals sine squared t. And at the same time, y divided by 4 squared equals cos squared t. So if you add these two together, you get x squared over 16 plus y squared over 16 equals sine squared t plus cos squared t. Okay? I could take my time so you don't skip too much steps. I take my time and you don't get too confused. Leave it as my bracket first. That's what Brandy has done. Is everyone following this? Good. All right. So this is x squared over 16, y squared over 16 equals 1. So Brandy, you can multiply through. What he is saying is x squared plus y squared divided by 16 equals 1. It's implying this is x plus y all squared divided by 16 equals 1. This is wrong. Because this is x plus y times x plus y. And that should be x squared plus 2xy plus y squared. Okay, we can't do that. So we can't do that. So the only thing we need to do, the only thing you can do is to clear the fraction. In fact, from here, you don't need this actually. Clear the fraction by multiplying all through by 16. This time 16, x squared. That time 16, y squared. And that time 16, 16. So this is your distinction. Okay, everyone? How about I try this? I want to make it more complicated. Or even, okay, something similar to that. Just to review the correction we just did. I'll take it from question 22. So x equals 3 cos t, cos, not cos. Excuse me. And y equals 2 sine t. Okay. Express it in that form, in the simplest form. We're done with that. I need you to attempt 9. Sorry. I'm waiting for replies on 8. If you're done with 8, can you type 8 done on the chat? And I call on someone to tell us the answer they got. Okay. I have 2 8 done, 3, 4, 5, 6. So, 1, 2, 3, Crystal C, 4, 5, 6, 7, 8, 9, 10. Calista is 10. One person is yet to reply. Me, okay. Leo, are you finding it difficult? Stop at the last step. So give me what you have. Leo, your mic working?
So the last one, x squared over 9 plus y squared over 4. I don't know how to.
That's not the last step.
It's my last step.
No. Look at your book again.
My book. Okay.
I can see your book from here.
My book.
Just kidding. X over 9 plus y squared over 4. That's it? That's all you have?
Yeah.
That's
Equals
not,
1.
equals 1. This is different from when it's equals to 1. You have to complete it. Do you know what I did here?
Yeah.
How did I get this 16 that I multiplied with?
You times 16 over 16.
Why 16 or why 16? I mean, that's the point. I didn't times 16 over 16. I only multiply by 16. So I multiply this by 16. I multiply this by 16. I multiply this by 16. I can multiply through. If you have x plus 2y equals 1, you are free to multiply by the same number. I can multiply by 3 and get 3x, 6y equals 3, correct?
Yes.
I haven't changed anything, have I?
No.
Because if I write 1 over 2, I can decide to write it as 4 over 8. It's the same fraction written in different forms, so they are equivalent, right? So I'm trying to find equivalent solution by multiplying by the LCM. Multiplying by the LCM. I called my mom and now she's calling back on WeChat. Oh my God. 18
times 18?
I'm not, hold on. I'm saying I multiplied by 16, all right? Well, there's a reason to multiply by 16. Do you know why?
LCM?
LCM. So in this case, what is the LCM?
18? No?
No.
Huh?
4 and 9 was the LCM?
9, 4, 18.
No. 4
times 36.
Exactly. So you multiply through by 36 this time. So tell me what you have.
Wait. 36 x squared plus 36. Wait, no. 4x squared plus 9y squared.
Good.
Equals 36.
Exactly. That's it. Did everybody get that? That's what you must get, everyone. Good. All right. So number 9. Can I see it done? Number 9. Good. Continue with 10 if you're done with 9. What? Is that done? 9 and 10? Start off. Mr. Start off. All right. So number 9 done. Yeah, maybe you don't have to. So you don't have to expand. You don't have to. Not even maybe. You don't have to. Then I'm done. Okay. So wait quickly. Anybody needs help with 9 or 10 or both? Mr. Cheng and Lillian, can you guys try 44 and 45 from the worksheet? 44, 45, 46, just make attempts like extension work. 44, 45, 46. Were these guys sleeping when I was sending all this? Edmodo, please. I'll attach it here. Let me see if I can attach it here. Can you download from there? All right, send it to WeChat also. Which question again? 44, 45, and 46. I don't know what you mean by the way eliminate H or R. The parameter is T throughout this paper, like I said from the beginning. Lillian, yes. Is the equation of a circle. Yes, you're right. 44 is the equation of a circle. looks like 46 and 49 are the same thing. So I'm going to have to remove that question and replace it with something else, if anyone has noticed. So I want us to practice some exponential forms. So you can see I started with algebra. Now we're in trig functions. So the last set will be exponential function. 1 or 2 questions will be enough for that. Okay, still on question 9 or 10, what I wrote on the board is extension work for anyone who has completed question 9 or 10. So outside Lillian and Ethan, can I have responses from the rest of the class regarding question 9? So can I see you type in question 9 done or something like that, so I know what's going on with you? If you have questions, okay, Brandy said 9 done. Karen, okay, 2 people more. Okay, 3. Leo not yet. Now Krista, Don, Krista. Oh, you guys are so confusing me. I like it, it's fine. All right, Clarissa. Is anyone struggling with it? You need help with it? Anyone? Talk to me, guys. Struggling with it, or you just need more time? Because this shouldn't take longer time, actually. So unless you're struggling with it. Hello? But not yet, people. Question 9. Are you struggling with it, or you just need more time? All right. Time to do 10 now. Nakita, so does that mean you've done number 9? Yeah, okay. All right, so quickly, please. Explain geometrically. Yeah, just like the video I sent to you, what happens on the plane as a result of what you have got. What question are you referring to? You can send me the picture on WeChat. Then maybe I can give you more explanation if I understand the context. Is that okay, Lillian? That must be from the last homework that I gave you. You just sent now or before? When my WeChat is open, I can't see anything. Where did you send it to? Space. Okay, Clarissa done. All right, just received Miss Alien. Okay, say find the blah blah blah. 4-2. What do you mean 4-2? Oh, okay, I see it. So question C1. All right, I'll have a look. And get back to you. All right, good job. 9 done. All right. Stuck at 46. Transfer 6 again, the last one, right? Go to the trig identities. Go to the trig identities. Now this involves what? Sec and tan. So which of these identities involves sec and tan? This is sec and tan. So have a look at this. It's what you need. Is that okay, mister? Yeah. So that's why I wrote the trig identity. That's why the extension work. So it's not normal work. Remember I said 46 and wait a minute. Did I put here AA instead of AB? All right, that's fine. So I'll change 46 to AA. Then I leave 49 as AB. Okay. Maybe I use different parameters, alpha and lambda, so it's not so confusing. So I change 46 and 49. So 49 is edited. All right, because 46 and 49 looks the same in the worksheets, and it's actually different from what I wrote as the class activity. So I made the class activity 46. Oh, I sent the worksheet to you privately, sorry. All right, so I'm sending to the class now. All right, so I sent it to the group WeChat. Okay, Mr. Chang, I received your picture. I'm looking at it now. Yep. Yeah, but question 11 in your paper, can you show more steps? I don't appreciate that last step without showing something concrete, how, but that's correct. And the other one, how do you get why do you have B, BX, HX? Where does that come from? Where does BX, HS come from? Number 12. I don't think that's is correct, Mr. Chang. Talk to me, guys, whatever problem you have, so we don't waste too much time here. All right, well, maybe we just do the correction because of time. So shall we do question 9 together? Can I have everybody's attention? Can I get a yes in the group chat? All right. So 2 ways to do this. First way is to leave this the way it is and try to, or just square both sides. Yeah, square both sides. I think that's even the easiest way. Square both sides, x squared is equal to sine squared t, which means y equals sine squared t becomes y equals x squared, right? So your equation is y equals x squared. That's it. That's it. That's the easiest way to do it. That's the easiest way to do it. There are other ways. I could write this as y equals sine squared t, which sine squared is cos squared t minus 1. So I could say y plus 1 equals cos squared. And from x, my x squared is equal to sine squared. And if I had both sides, I get y plus 1 minus plus x squared is equal to 1. And this also gives me y equals, is that negative? Tell me something I wrote wrong, guys. Because I'm supposed to get the same thing. No, that's cos squared minus 1. 1 minus cos squared. Yeah, 1 minus cos squared. Thank you, Crystal. But you could see that this is unnecessary calculation. Okay. So from here, y minus 1 equals, so I write this first, y minus 1 equals negative cos squared. So it means 1 minus y. I flip everything now. Even from here, I could flip from here. If I want to make cos squared, see the subject on this side, I'll get 1 minus y. So 1 minus y is cos squared. So it means this becomes, we had 1 minus y plus x squared equals 1. So clearly, negative y plus x squared equals 0. So y equals x squared again. So what's in point of all this when you could just quickly do this? Okay. So that's all about that. And for this, from here, x minus 2 equals 3 cos t. So x minus 2 divided by 3 equals cos t. From here, y minus 4 equals 2 sine t. So y minus 4 divided by 2 equals sine t. We square both sides and add. It means x minus 2 all squared divided by 9 plus y minus 4 all squared divided by 4 equals cos squared t plus sine squared t, which which is equal to 1, of course. So if you multiply it through by 36, you get 4x minus 2 squared, 9, y minus 4 squared equals 36. Does everybody get this? Anyone? So make attempts on this extension on your own. We only have a few minutes and I don't want us to spend extra time. So we might be revisiting the second part before we begin a new topic tomorrow. But before we go, in the next 5 to 7 minutes, let's look at the exponential forms. Okay, let's look at the exponential forms. So I'm talking about questions from 35 to 41. We'll just take 1 or 2 and that's it. Message received, Mr. Cheng. So question, let's say question 11. Can I ask you to attempt x equals 2 to the power t, y equals 2 to the power negative t. Attempt that. X equals 2 raised to the power t, y equals 2 raised to the power negative t from question 35. I'm still not satisfied with that solution, Mr. Cheng. I saw your new updates. On your question 10, that shouldn't be the last step of your question, as you have seen the correction we just did. Anyway, everybody focus on 11, and I'll put one more. We take question 12 as 39. That will be the last one today and for this aspect. So this is parametric to what's it called? Parametric to Cartesian. Maybe not. Can I have exponential and algebraic? If you have exponential and algebraic, you can begin with algebraic or you can begin with exponential, it doesn't matter. So worst case scenario, you get your answer in terms of exponential or you get it in terms of log toward the appropriate base. To answer question 41, I will advise that you look at how to express hyperbolic functions in terms of exponential. I've not done it, but that's what it's looking like. So you might want to look at that for anyone who wants to make an attempt. It's not going to be like any activity for the class. Has anyone done 11, please? Oh, great. Sorry. So you were waiting for me to write something. Okay, let's take 12 as 39. let's take 12 as 39. X of t equals exponential negative 2t. Y of t is 2 exponential negative t. Now, let's take that. And this was what led to all this deviation. Take that from question 47. X equals 3t minus 8. Y equals 2t minus 4. And Z equals t. Received your work, Nakita. That's correct. That's an 11. Perfect. It's not 2, but Z, so I put a stroke here. So since most of you have done that, so you start from Y here because it has negative. You're lucky that you have the same base, so there's no need to panic. So Y could be 1 over 2 raised to the power t, and this is your X. So basically Y equals 1 over X. So the function in terms of reciprocal, the rational function basically. And of course, you put the condition here, X is not equal to 0. Nakita, can you do that? That's X equal to 0, Y is not defined. Yeah, so it doesn't pass through the origin basically. It doesn't pass through the origin. You can try to plot the graph on Desmos. Let me show it to my screen. We try to plot the graph, Y equals 1 over X. And you see, it does not pass through the origin. Everybody see that? This is Y equals 1 over X. So that's why you need that condition. Do you guys understand what I'm saying? This is the graph of Y equals 1 over X. So that's why the condition is very important. That, oh, X is not. Because you're trying to say that the function is defined. Okay, so you have to exclude where the function is not defined whenever you write a function. And because we are written it as Y equals 1 over X, we need to say, oh, X is not 0, by the way. If it was Y equals 1 over X minus 1, then we put in the brackets X is not equal to 1. That's not, just to make it defined. Okay? So, does anyone try 12? All right, so let's quickly do this so that we can leave. So I think this is easier to start with again. From Y equals to exponential negative t, I can square both sides. Y squared equals to exponential negative t squared. So Y squared equals 4 exponential negative 2t, and this is your X. So Y squared equals 4x. It's easy. Last but not the least, this is what led to all this. Z is already in terms of X, so definitely X equals 3Z minus 8. from which x plus 8 equals 3z, from which x plus 8 divided by 3 equals z. Also, y will be equal to 2z minus 4, from which y plus 4 equals 2z, from which y plus 4 divided by 2 equals z. Yeah. So if you use this, and this, so I can say equation 1, 2, and the fact that oh yeah, no, equation 1 and 2, that's okay. There's no other fact. So equation 1 and 2 implies that x plus 8 divided by 3 equals y plus 4 divided by 2 equals z, because we have to write it in terms of the 3. Okay? The only thing you could do is to try to eliminate the fraction. So twice of that, twice of that, 6 times of z. That's all you can do. Unless, of course, we want to write it as 2 different equations. Okay, if we write it as different equations, in fact, 3 different equations, we can write as 3 different equations. If we want to do that, so we could say from this, from 1, or we could say from 1, if you do not want to leave your answer in this form, from 1, x plus 8 equals 3z. So basically, x equals 3z plus 8 minus 8. And from 2, it's like just separating them like the way it was in the beginning. So basically, you have y plus 4 equals 2z. Actually, that's like going back anyway, so 2z. You understand my point? So y is equal to 2z minus 4. So remember, you have 2 equations in 3 variables, and that's why you have infinitely many solutions, which was which necessitated writing in parametric form. You guys understand that? So you have 2 equations in 3 variables, so you are underspecified. And that is why you have the equation in parametric form. So you're welcome to leave it in this form, especially in this form, all right? Unless otherwise stated, you can leave it on this form. Does anybody get what I just did? I've eliminated the variable. Of course, it's not gonna look like the way it was before. We will talk more about these 3, the ones with 3 equations in vectors. When discussing plane and vectors in plane, we'll talk about that. How do you get 2z? You're supposed to multiply through by, yeah. How do you get 12z? You want to tell us, and be fast, please. The first 2 equations are equivalent, yeah. So how does the 12 come? Where does the 12 come from? So if they are added, you're right. You're right. You're right. I think I like that format too. If you want to make it 1 equation, yes. Yes, if you want to make it 1 equation, yes. So what the thing is talking about is this. If I'm making it 1 equation, then yes, I'll take that. So this is what is saying. From this 1 and 2, add 1 and 2. We had 1 and 2, x plus 8 over 3, y plus 4 over 2 equals 2z. Okay. In case we do not want it in this form, because we want to have it in form of one equation. Okay, one equation in three variables, So this is 2 equations in 3 variables. So we can now multiply through by 6. So you get your 2x plus 8, 3y plus 4, and this is 12z. Okay, then you have to simplify, Mr. Cheng. Open the bracket. Open the bracket, you have 2x plus 16. You have 3y plus 12 equals 12z. So the implication of this, if I may write it here, is that you're going to have 2x plus 3y minus 12z equals negative 28. So you're right. They're all in Cartesian form, Lillian. They're all in Cartesian form. Okay, everyone? So this is another O, which ends here. Okay. Personally, which one I preferred? Anyway, I don't have any preference. I don't have any preference. But I don't like this format unless you're asked to write it in, maybe generate the equation that led to this. Generate the system of the equation. If you're talking about system of the equation that led to this, or a system of 2 equations, then of course it's specified. System of 1 equation, of course, that would be this one, okay? But otherwise, you just leave it in this form, because from here, you can formulate either this or this. So I think I would probably say this one, because it's like this will lead to the other 2 formats, okay? This one and this one. This will lead to that. But it doesn't matter. Anyone you do is fine. Questions, anyone? Because we have to go now. All right, so there's no homework. Enjoy the rest of the day. Do whatever you want. If you want to practice more, use the updated version of the worksheet. And I'll see you tomorrow. We'll look at the reverse of this process. I will need to explain something on the equation of circle that Lillian mentioned earlier in case you do not have an idea. Can you still see me? Because I minimized my video. Can you still see me? All right. So, Mr. Chen, you said something about what did I do wrong and blah, blah, blah. Okay, if I may, quickly class, sorry, before you go, just to quickly share that. So this is, can you see this? Can everybody see that? So we can all learn from it. So nice try here, okay? Nice try. First, you can see the cursor, right? Okay, good. So first, you need to simplify this further by having 9 and 4 with the square only on this. Don't expand and clear the fraction. Second, can I have space, enough space in between? Okay, because I have enough space in between. And so when you are doing this, can you show how you add it? When you add, you're supposed to have this r square cos square x, r square sine square, r square sine square t, cos square t, r square sine square t first. On the next line, show us how you factorize r square brackets, cos square plus sine square in the bracket, which led to 1 before you write this. Then it's acceptable, okay? Here, I don't know where you got this b from. So basically, you had that, then you multiplied by some random b, I guess because there's a b on the other side, well, you must have your reason. Then also here, I think I get it now, because initially you had something that doesn't make sense. So I think you have adjusted that. So AY minus, so again, this is meant to be Y minus K first before you multiply by your random A, and I guess because A is from here, so that's also allowed. Then you square both sides, and I want to see the factorization again. Can you hear me, sir? So I want to see you add them on both sides, and I want to see how you factorize, and I want to see how you got 1. But you don't have to do this, that's the point. You could do exactly what we did here. Okay, because I didn't see you say x minus 2 times 2, x minus y minus 4 times whatever here. So you don't have to make life complicated for yourself. So you could just do x, then here, this is correct, like I said. So you could do x minus h divided by a in the third step, of course, y minus k divided by b, all right? Then you do the square both sides and you clear your fraction. So that's also allowed. So this is okay because, of course, you knew what you wanted, so you walk towards it. So this is okay, but just show more steps, all right? But you could do it easily in this way. And I hope everybody learned something from that. This is the extension work that he attempted, and it actually makes sense. So this also looks good so far. You just have to, you don't have to divide this time because you have AA, right? So you could just square both sides and add or subtract depending on whatever you want to do. The reason you are multiplying by your random letters here, that you are not doing exactly what here you did just addition because you had the same R, and that's the same case here. But here you had to multiply by something, and I'm proposing that you can also do it this way because there are different numbers. The number here is a 3, the number here is a 2, so that was why you had to divide first before you square. So you could also divide first before you square instead of using this method, but the method is correct. But it could be confusing for any beginner, but this is easier. Okay, but this is perfect. You don't need to change it, just show more steps next time. Questions from anybody? Questions? Nope. All right. So please take note of this. Make use of some of the hints he has given us from his work. I'll see you guys tomorrow. You can say bye to the class and exit the meeting room.